Everyone, it's Justin again. We've been busy in my backyard lately. We've planted a garden, which is growing strong. We've built a birdhouse, we've put up a fence, and we've even installed a pool. And each time, we've used square roots to help with our projects. So far, we've taken the square roots of numbers we knew, but that got me thinking. What happens when we try to take the square root of something else, like a variable? Is that even possible? Do you think square roots work the same way when variables are involved? Let's take a closer look to find out. When we took the square root of a number, like the square root of 9, we had to ask ourselves what number times itself, or squared, equals the radicand. Remember, the radicand is the expression under the radical. Since 3 times 3, or 3 squared, equals 9, we know the square root of 9 is 3. So I wonder, can we ask the same question to find the square root of a variable? Let's try simplifying the square root of x squared. What squared equals x squared? Well, isn't it just x? X squared equals x squared. It sounds kind of silly when you say it like that, but it's true. We can also think about this in terms of multiplying. What times itself equals x squared? Again, it's just x. To break that down, remember what we've learned about variables with exponents. What exponent do these x's have? If no exponent is written, an exponent of 1 is implied. So we could write this as x to the power of 1 times x to the power of 1. When we multiply terms with the same base, like x here, what do we do with the exponents? We add them. 1 plus 1 is 2, so x times x equals x squared. And that means the square root of x squared equals x. Okay, let's try one with a bigger exponent. Simplify the square root of b to the power of 6. We'll ask the same question here, and since we know how to multiply variables with exponents, we'll focus on multiplication. What times itself equals the radicand, b to the 6th? If we're multiplying something by itself to get b to the 6th, what variable would it need to have? It'll still be b, the same base. But what exponent would we need? Remember, when we multiply terms with the same base, we add their exponents. So, what value plus itself equals 6? 3. B to the third times b to the third equals b to the 6th, because 3 plus 3 equals 6. This means the square root of b to the 6th is b to the power of 3. Variables represent unknown numbers, so it makes sense that square roots of variables work the same way as square roots of numbers. That means we can ask the same question every time. What times itself equals the radicand? I think you're ready to try some on your own. Simplify the following square roots. Pause the video and try these in your guided notes. First up, the square root of z to the power of 4. What times itself equals z to the 4th? It's z squared, because when we add the exponents, 2 plus 2, we get 4. That means the square root of z to the 4th is z squared. On to the next one, the square root of a to the power of 10. This one's a to the 5th, because when we add the exponents, 5 plus 5 equals 10. Looking at the square roots we've found so far, do you notice any patterns between the answer and the original radicand? Pause the video and write down any patterns you see in your guided notes. When we took the square root of a variable with an even exponent, the answer always had the same variable as the radicand, with an exponent that's half as big. That's because when multiplying terms with the same base, we add the exponents. Adding two matching exponents is the same as doubling the exponent. So if we double the exponent of the answer, we get the exponent in the radicand. That means we can find a square root by dividing the radicand's exponent by 2. So far, we've only found positive square roots, but remember, with numbers, we had negative square roots too, because, for example, both 3 times 3 equals 9 and negative 3 times negative 3 equals 9. Do you remember the notation we used to show a negative root? How about both the positive and negative roots? We just write a negative sign in front of the radical to indicate the negative root, and we write the plus or minus symbol to show that we want both roots. Do you think we can have positive and negative roots of variables too? Well, we already said that variables represent numbers, so they should follow the same patterns that numbers do. Let's take a look at what this means for square roots with variables. Simplify plus or minus the square root of m to the power of 8. First, we'll just think about the positive or principal square root. What times itself gives us m to the 8th? M to the 4th. So the principal square root of m to the 8th is m to the power of 4. Now, how do we write the negative root? We'll just put a negative sign in front of m to the 4th. Pay close attention to the notation here. This should be written without parentheses. If you write it with parentheses around negative m, it means the negative sign is raised to the 4th power 2, which would make it positive. So let's double check that our negative root is correct by multiplying it out. It's just like multiplying two negative numbers together. We ignore the signs and multiply the variables. M to the 4th times m to the 4th is m to the 8th. Then apply the correct sign. Negative times negative is positive. So we still get positive m to the 8th. Since we're simplifying plus or minus the square root of m to the power of 8, we need to include both roots in our answer. Remember, there are a few ways to write it to include both the positive and negative roots. Any of these options work. Time for one final example. Simplify the following square roots. Pause the video here and complete these in your guided notes. First problem, we know we need our negative root because there's a negative sign in the original expression. But we can start by thinking about the principal root first. What's the positive square root of c to the 12th power? C to the 6th. So for the negative square root, we just include a negative sign. Negative c to the 6th. For the second part, we need to include both the positive and negative square roots. The positive square root of k to the 16th power is k to the 8th. So the negative square root is negative k to the 8th. Be sure your answer includes both roots with proper notation. Check that your answer matches one of these three. Even though we don't know what numbers these variables represent, we can still indicate the positive root, the negative root, or both. That's because variables are just placeholders for numbers, so we can work with them just like we work with numbers. Thanks for exploring square roots of variables with me today. Since variables represent numbers, we can use the same strategies to simplify their square roots. Just keep asking that big question, what times itself gives me the expression under the radical. For now, finish up your guided notes and then complete levels 1 through 4 of the online practice. Until next time, keep questioning, keep calculating, and remember, the answer is always hiding under the radical. Just ask what times itself got it there. See you next time. Hey, hey.